Welcome everyone. Today we're going to talk about Enviroline 405 HTR. It's an epoxy Novolac tank and vessel lining, and it provides fantastic value for owners, facility owners, engineers, everybody in the oil patch, everybody in the oil producing arena. My name is Mike O'Donoghue. I'm an Englishman from the University of Surrey with my PhD. And I've been in the protective coatings and marine business for about 35 years or thereabouts. It's been exciting to publish many, many different papers, and some of the topics are covered today.
And my name is Vijay Datta. I have a master's in chemical engineering from New Jersey Institute of Technology, New Jersey. And I have over 50 years of experience in the marine and protective coating industry. And I have authored about 70 papers which have been published in the various magazines related to protective and marine coating segment.
Well, let's begin our little journey and start by, I think, a great quote actually from Carl Sagan. He said long ago, extraordinary claims require extraordinary proof. And with respect to coatings, not all coatings are created equal. And we're going to look at a fantastic coating today.
I agree with you, Mike. All coatings are not created equal. Before we dive into that, let's talk about why and where we line tanks and pipes. So the first one is why we really line the tanks. There are three reasons basically here. The number one is the corrosion protection for the cargo tanks. So we have to put a coating there which acts as a barrier between the steel and the cargo. Number two is the protection of the product purity of the cargo. And the last one is that there are some chemicals, such as ethanol, they may cause stress corrosion cracking of the well. So we have to line the whole tank. Now, where do we line these tanks? They would be in the refineries, chemical plants, tank terminals, water, wastewater facilities, and also oil producing and processing facilities. Now, talking about the technology, let's talk about what are the improvements which has been made in the lining technology. Number one is everybody's making higher and higher solids products, which gives you lower solvent emissions, and you can apply this coating in a single coat because they're high build. They're very fast return to service, which gives you more productivity. They also can handle various high temperatures and variety of cargoes. And of course, they give you a very improved chemical resistance to all sorts of chemicals, which can give you a longer lining service life.
If we're dealing with the oil patch, there's some very interesting key challenges that we have to face. We have very high temperatures, as you've mentioned. We have hydrogen sulfide gas and carbon dioxide gases. These are acid gases, and they ravage steel, and they certainly can cause all sorts of problems with coatings, so we have to deal with those. Obviously, there's oxygen, water, and we have salts as well, 100,000 parts per million salt in some of these vessels that we're dealing with, for example. And then the substrate itself, well, you have chlorides to contend with, sulfates, soluble salts, and you have insoluble materials like sulfides, which are cathodic to steel. So there's quite a few challenges that we have to deal with when we're dealing with these coatings.
That's right, Mike. And in addition, there are additional challenges for the linings here. Like you mentioned, a very high temperatures. Yes, when the crude oil is very heavy, that we need a very high temperature processing facilities, more than 300, 350 degree F. High pressure, more than even 1,000 PSI. Rapid depressurization that can really cause a lot of problems for the coating. And there are very high levels of hydrogen sulfide and carbon dioxide. Chemical inhibitors, and a lot of people are putting different performance enhancement chemicals which can really affect your coating.
And with that in mind, then, we need to have an epoxy that can handle all of these different factors. And in order to sort of grasp how good, say, 405 HTR is, we could first look at just the simple Epoxy-Amine cure reaction, from which you can then take as Vijay into the actual formulation, you being a formulator. In the big scheme of things, it's a simple reaction, essentially, between an amine, which is a curing agent, and an epoxy, the base and the curing agent. And you form, when you react them together, a little bit of a love affair between the oxygen and the hydrogen atoms, the oxygen on the oxyrane and the hydrogen on the curing agent. You form a primary amine. That primary amine then reacts further with more of the epoxy base to form a secondary amine. And so the reaction goes on to form a tertiary amine and a cured film.
Enviroline 405-HDR, as we said before, is used as Epoxy-Novolac base, and also it uses Polycyclamine curing agent. Now, the difference here between the 376 and 405-HDR is that 405-HDR uses the Novolac resin, which has a very high functionality. So when you cross-link it with Polycyclamine curing agent, it gives you a very dense cross-link density, which gives you excellent chemical resistance and high temperature performance. And what we try to do here again is we try to keep the free volume very low so that it can give you least penetration from the cargo. Now, polycyclamine cured epoxy Novolac can offer varieties of advantages. Very superior chemical immersion resistance, like I mentioned before, because they're very tightly cross-linked with the high functionality Novolac, high temperature resistance, thick film system for excellent long-term barrier protection here, very ultra-high solids, which gives you very low VOCs, and that can give you over 60 years of performance for various tank linings.
There's a fingerprint factor that's worth identifying for people around the world. In different areas of the world, when you buy Enviroline 405 HTR, what you buy in Asia is the same in North America, and in the UK, for example, it's exactly the same. So we literally have a fingerprint of the coating formulation, so that wherever you are, you're going to get the same product in around the world. And if we think about the virtues of this wonderful coating, one of the things that really arrested everyone's attention was single leg airless. A single leg airless, and you can use it very easily, therefore, and you have a pot life of about 50 minutes. You can use it, of course, with the hydrocats, and that's normally how it would be applied. But it's a single coat application from 20 to often 60 or 70 mils or thereabout. And as you mentioned before, you get, because of that fabulous cross-linking, high temperature resistance and resistance to 300 Fahrenheit with some of the materials that we've been talking about. What's gorgeous about it is the fast cure. And if we look at the curing aspects of it, we'll see that you can be in service in 10, 14 hours or so walking on this particular fully cured lining, as opposed to a standard one, which is like, for example, 7 days at 77 Fahrenheit. So we've got a lot of things going for us, haven't we, Vijay, in that regard, with the reduced application costs being one of the big aspects for the contractors and the facility owners. But the wide range of chemical resistance, tell us about that.
That's marvelous, Mike. And so let's see now where this typical 405 HDR can be used. It can be used in the various petroleum storage tanks, downhole casings, upstream process vessels, and interior and exterior of various pipes, and also water knockout treaters and separators.
In terms of the actual formulation, as you mentioned earlier, it's a polycyclamine cured epoxy, but we have in there a flake and fiber reinforcement. So it's actually a reinforced Novolac tank lining, and it's resistant, as we've said, to about 300-ish Fahrenheit, 150 centigrade, solvent-free, ultra-thick film, what we've talked about before, but key here, approved and are used by many oil and gas owners, majors worldwide. And you're going to come to this, conforms to API 652, 653. So we can get 10 years or thereabouts with inspection intervals being that long, because we've got this conforming to the API. Where are we using the Enviroline 405 HDR? Pipe exteriors, biofuel storage, natural gas extraction, and as we mentioned a few moments ago, petroleum storage tanks where we can have large inspection intervals, all while we're maintaining temperatures around about 300 Fahrenheit or thereabouts.
Let's see some of the chemical resistance what 405 HDR can give us. It has excellent resistance to sweet and sour crude, resistance to many aromatic and aliphatic hydrocarbons, a lot of resistance to acid scrubbing amines, which is really important here, and very aggressive solvents it can handle. There's a wide range of chemicals, including ethanol and gasohol, which it can handle. Now, let's move into the testing, because like we mentioned before, all coatings are not tested equal. We do a lot of testing for Enviroline 405 HTR. We run the autoclave test at various temperatures with the gas phase, water phase, and the hydrocarbon phase. In this case, you can see here there's a 5% H2S, 5% CO2. The balance is methane. And then hydrocarbon phase is the sour crude, and along with the water phase, which is 5% sodium chloride. We also run Atlas cell, both standard Atlas cell as well as pressurized Atlas cell in 3 phases. Flexibility, hot water soak, because that's required if you want to conform your coating to the pipelines, and impact test, which is really important here. As you can see here on the top, we have an autoclave set up here. It's like a pressure cooker, which can have 3 phases, gas, hydrocarbon, as well as water. And what we will do is we run this test for several months under different temperature conditions, and then we measure the EAS values, which is electrochemical impedance spectroscopy, that gives you the barrier properties. And then at the bottom, we have Atlas cell set up there, cathartic disbondment, impact, and flexibility test. As you can see here, some of the results here for the autoclave. We give excellent adhesion, both in the autoclave as well as in Atlas pressurized cell.
We mentioned in the 376 discussion, the impact resistance is similar with 405 HTR. Even at -30 centigrade, there's no cracking with this coating if you test the panels, and the flexibility is remarkable. It's by 0.85 degrees per pipe diameter length. Lots of times, many times, we go to different independent third-party laboratories to test these coatings. Often you'll find that they'll be tested not just the 5 and 5, the 5% hydrogen sulfide, the 5% CO2, but we'll even go up to say 10, 20, and sometimes even 50%. And these coatings, with 405 HDR being preeminent really amongst them, that handle some very high temperatures and large proportions of acid gases. We also do the cathodic testing, cathodic protection testing, by looking at the disbondment, and we obviously do very well. This particular one is ASTM G95, but we've done the CSA Z245s as well. And what we see with the cathodic disbondment testing, very small amounts of radial disbondment, which are fully in compliance with the testing criteria that are required for that testing.
Now, like we mentioned before, that this is used as a very high functionality Novolac resin, and is very tightly cross-linked for very good chemical resistance. And here is the several good chemical resistant features here of this coating. Is a resistance to low concentration of caustic, which is very aggressive, in fact, more aggressive than the higher concentration. Ethanol, resistance to ketones. MIBK is a ketone, which is very aggressive, and so is the salicylic acetate. It's a resistance to acid scrubbing amines, which a lot of coatings cannot handle. So that gives us a very good advantage to be used in the oil processing facilities. And it has enhanced mechanical and barrier properties due to glass fiber and flake reinforcement. As you can see here, with a chemical immersion test, which we ran for a very extended period of time, just to give you an idea, several chemicals here, which I mentioned in the previously, and they won't give you any blistering, rusting, cracking, and there would be some discoloration in certain cargoes, but that's not considered a failure. And the typical adhesion is fantastic here, you know, in the high 14 to 1500 PSI.
With amine chemical immersion testing on coupons, we found that the Enviroline 405 HDR passes 120 Fahrenheit all the way to 176 Fahrenheit, which is 80 centigrade. You'll see in each of the solutions, one being 30% monoethanolamine, 50% methyl Autoclave, I can hardly say it, 50% diglycolamine, it passes all of these particular tests. So it's particularly resistant because of the very thing we were talking about earlier, where the cross-link density of this coating is particularly very good, very tight cross-link density. And in this next particular picture, we can tell that the adhesions after we've done the testing are still greater than typically 10 MPa. Great results from that particular 405 HTR. But as with all things, if you don't put it on right, testing in the laboratory is just nothing but an indicator. You have to do it right. So we need to have a good near white metal blast, like you see on the far left, and the scanning electron microscope shows what it's really like on the middle. You need a jagged angular profile of around about 2.5 to 3 mils for that coating 405 to adhere and adhere very satisfactorily. But in real life, of course, when you're inside of an above ground storage tank, oftentimes you don't have a nice blast profile like that. You've got a surface to begin with, which is pitted, oftentimes with omega pits that you'll see, where we have to make sure that we get inside that particular pit and deal with it. You'll come to that, I know, VJ. So that's one of the challenges there with that pitted steel. And in this next quick slide, you'll just see that the coating, when it's applied on the surface, looks rather like the moon, as with covering the craters, as it were.
So when sometimes the coating has to be applied over heavily pitted steel, Mike, like you mentioned before, and in that case, it's usually recommended that we apply a holding primer, so that the thin holding primer, which is also a high performance primer, which can really fill into those pits and cover those pits very nicely. And then we will either spray apply it or squeegee the 405 HTR on top of it. So after that, we have to do the holiday detection test. That's really, really important into this coating. You don't want any pinholes into the coating here, because that would be a disaster, and that would be the point where you're going to see all the rusting happening. So for thin film coating, which is less than 20 mils, normally we will use a low voltage wet sponge test. And for high voltage spark test, which is more than 20 mils, we normally use 100 mils, 100 volts per mil. And that can really give you wherever the pinholes are. And that's really important to do this test after the coating is cured.
Case histories abound all over the world. And here's just a simple one, actually. 40-foot diameter, 30-foot tank. And the temperature is 190 to 200 Fahrenheit. Produced water. It's very aggressive. Water is extremely aggressive. One often doesn't think that. So this particular lining application is where a facility owner said, this is the only coating I will use, and it was so specified. And here's another example where I hail from in the Canadian oil patch. The Canadian customer, he had all sorts of independent tests carried out. The 405 HTR worked really well to his satisfaction. It was so specified there. We got 75 diameter tanks down at 180 Fahrenheit with reduced water and different sized examples that you can see. But it's symptomatic of great success, great approvals worldwide.
So let's see the performance of 405 HTR at a glance. Number one is it has a proven performance. It has a long history of proven performance in various tanks and oil processing facilities. It has a very quick cure, so you can put the tank into service very quickly. It is a reinforced, so it can be applied at very high dry film thickness, which can comply with API 652. And it has a low temperature cure. A lot of coatings don't cure below 50 degrees or are not recommended. This coating can even cure at 40 degrees Fahrenheit.
One of the great beauties of that particular lining, VJ, is its large temperature resistance. We've obviously used it up to 300 degrees Fahrenheit, and we've actually tested way beyond that too. One of the real delights is that it's solvent-free. And as long as we're applying it properly with the hydrocats, etc., we get fabulous wetting out of the surface. And as a result, with the good success we're enjoying, approvals abound with the oil majors.
Now, we have written several papers, Mike and I both together, regarding tank lining publication. As you can see here, number one is published in March 2019 in the JPCL magazine. penny wise, pound foolish. This is a fantastic paper with the value of the holding primer when the steel is especially pitted. And as you can see there, there's a JPCL paper written in November 2019, PIC magazine, corrosion management and SSPC proceedings in 2018. So there's several papers written regarding the use of the tank linings.
As we close, I'm going to ask you a question. What of those papers do you like the most and why?
Mike, really the favorite paper is the first one here, the JPCL paper, March 2019, penny wise, a pound foolish. I think this paper really describes you the value of the holding primer, and especially in the pitted tanks. A lot of people think it's like it becomes a two-coat system, but eventually it saves you a lot of money.
Thank you, everybody, for your attention. From Mike.
Thank you.
Thank you.